Good morning, everyone. In this video, we are going to start with chapter 6 triangles. You have already studied triangles in your lower grades on congruency. Now, we are going to start with a new concept similarity. So, now two figures, any figure, is said to be similar if they have the same shape, same angle, but the sides are not same, they are going to be proportional. So for example, here you can see two rectangles. So both are the same shape and same angle, that is 90-degree on all the vertex, but the sides are not equal, they are going to be proportional. Same way with the trapezium and the circle, they are having different radii. So angle is 360, same shape also, but the sides are proportional. You already know congruent triangles, which means same shape, same angle, and same sides also. The only difference with similar triangles is the sides are going to be proportional. For example, here you can see ABC and PQR. Both are scalene triangles, isn't it? So same shape, same angle also, proportional because AB is 8.4 and PQ is 4.2. So when you see, it is half of it. This is BC is 6, QR is 3, half. AC is 7.8, PR is 3.9, again half. So all the sides will be of the same ratio. That is why we are saying sides are proportional. So if we have two triangles of this kind, same shape and sides are proportional, angles will be the same, then these two triangles are said to be similar. ABC is similar to PQR. Now let us move on to the first theorem, basic proportionality theorem. This is like a generalization of the midpoint theorem that you had already studied in the previous year. So let us see the theorem. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. So this is the figure for it. Now, it is given that ABC is a triangle and a line is drawn parallel to BC. So, parallel to BC, we have a line which intersects the other two sides at distinct points. That means it is intersecting AB at D and AC at E. What do we have to prove? That it divides the other two sides in the same ratio. So that means AD by DB is equal to AE by EC. To prove this, we are going to have a construction. We are going to join BE and CD and draw DM perpendicular to AC, EN perpendicular to AB. Okay. Now, to prove this, first let us consider area of triangle ADE, which is half base into height. Here we are taking EN to be the height. So EN and base will be AD. So half AD into EN will be the area of triangle ADE. Now again, we can say that area of triangle BDE will be half of dB is the base here and the altitude is En. Even if it is outside the triangle, we'll take the same altitude because it is from the same vertex to the base extended. So base we will take it as only dB, the height will be En. Now area of triangle ADE can also be written as AE into DM, the other height, the other altitude also we can take for the same triangle. So either En, then the base is AD. If we are taking DM, then the base is AE. Same way, triangle DEC, area of triangle DEC will be half of EC is the base and DM is the altitude. Okay. Now let us take ratio of these two. That is area of triangle ADE divided by area of triangle BDE. These two triangles we are taking, which is half AD into EN, half DB into EN. So half and EN will get cancelled. We'll be left with AD by DB. Same way, if we are taking ADE and DEC, DM and half will get cancelled. We'll have AE by EC. Okay. Now BDE and DEC, these two triangles are having the same base and they are between the same parallel lines BC and DE. So areas are equal. You have already studied this before, isn't it? So two triangle area will be equal if they lie on the same base and between the same parallel lines. So area of triangle BDE is equal to area of triangle DEC. So numerator here ADE is the same. Denominator is also equal, we have proved. So equation 1 and equation 2 are going to be equal. So from equation 1, 2 and 3, we'll have AD by DB is equal to AE by EC, which we have to prove. Now moving on to the second theorem. This is the converse of the first one. If a line divides two sides of a triangle in the same ratio, then the line is parallel to the third side. So the converse. Now using these two theorems, we are going to move on to exercise 6.2. Figure is already given to us. DE is parallel to BC. They have already given. We have to find AD over here. Now, suppose if we are taking AD to be X, given that DE is parallel to BC, so by basic proportionality theorem, we can say that AD by DB will be equal to AE by EC. Substituting the values, X by 7.2 equal to 1.8 by 5.4. Solving, we get X as 2.4. So AD is 2.4 centimeter. Now, since basic proportionality theorem is actually a named theorem, instead of writing the whole statement of theorem 6.1, it is enough to write by using basic proportionality theorem. Okay, now let's move on to the second question. E and F are points on the sides PQ and PR respectively of a triangle PQR. State if EF is parallel to QR. So this is the converse type. Okay, so they have given the values. PQ is 1.28, PR is 2.56, PE is 0.18 and PF is 0.36. We have to check if it is parallel. When will they be parallel? In the converse, they say that if they divide in the same ratio, then they are parallel. So let us check the ratios. P by PQ is 9 by 64. Same way, PF by PR, when we substitute the value and solving it, we get 9 by 64. So both the ratios are equal. Since they are ratios equal means proportional. So since their sides are proportional, we can say that EF is parallel to QR. Now, fourth question. In the figure, DE is parallel to AC and DF is parallel to AE. Say, DE is parallel to AC and DF is parallel to AE. We have to prove that BF by FE is equal to BE by EC. Okay, so for that, we'll write the given first. In triangle ABC, DE is parallel to AC and DF is parallel to AE to prove BF by FE equal to BE by EC. Now, moving on to the proof. First, we'll consider in triangle ABC, DE is parallel to AC. So by basic proportionality theorem, we know that BD by DA is equal to BE by EC. This will be the first equation for us. Again, let us consider the small triangle BAE. Here, DF is parallel to AE. Again, by basic proportionality theorem, BD by DA is equal to BF by FE. Now, comparing these two equations, left hand side are equal. So, the right hand side BE by EC is equal to BF by FE. This is what we have to prove. Hence, proved. So now, moving on to question number 5. In figure, DE is parallel to OQ, this face, okay, and DF is parallel to OR. We have to show that EF is parallel to QR. So this is a tetrahedron and two face, the lines are parallel. The third face we have to prove. So in triangle PQR, DE is parallel to OQ and DF is parallel to OR. This is given. We have to prove EF is parallel to QR. Now for that, first let us consider the triangle POQ. D is parallel to OQ. So by basic proportionality theorem, PE by EQ is equal to PD by DO, first equation. Same way in triangle POR, DF is parallel to OR. So PD by DO is equal to PF by FR, again by basic proportionality theorem. So we have two equations over here. From these two equations, we get PE by EQ is equal to PF by FR. The sides are proportional, so obviously EF is going to be parallel to QR by using converse of basic proportionality theorem. So in this question, we are using basic proportionality theorem 2 times and then we are using converse once in order to prove that the third phase is also having EF parallel to QR. Now moving on to question number 7, using theorem 6.1. Theorem 6.1 is basic proportionality theorem. So using that theorem, we have to prove that a line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. Okay, so the theorem states that they have to be, if it's parallel, then they are proportional. So need not be that the parallel line is midpoint. Okay. So here we have to prove in case of midpoint. What happens? That is what we have to prove here. So given that PQ is a line drawn through the midpoint P of the sides AP of triangle ABC and PQ is parallel to BC, we have to prove Q is the midpoint of the side AC of ABC. So we are having PQ. P is a midpoint, we know. PQ is parallel to BC, we know. We have to say that Q is the midpoint. Now, in triangle ABC, P is the midpoint. So, by using basic proportionality theorem on PQ parallel to BC, we can say that AQ by QC is equal to AP by PB. But P is a midpoint. So AP by PB will be 1 by 1. So we have AQ by QC is also equal to 1 is 1 by 1. That means AQ is equal to QC. So Q is the midpoint of AC. Now moving on to question number 8, using theorem 6.2, that means converse of basic proportionality theorem, prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. So this is the converse of the previous question. Okay. Now given that PQ is a line segment joining the midpoints P and Q of line AB and AC respectively, both are midpoints, and AP equal to PB, AQ equal to QC because they are midpoints. We have to prove that PQ is parallel to BC. Now for this, P is a midpoint of AB. So AP by PB equal to 1 by 1, first equation. Q is the midpoint of AC. So AQ by QC is 1 by 1, second equation. Both the sides are proportional. So therefore, by converse of basic proportionality theorem, we can say that PQ is parallel to BC. Hence, we have proved this one. Moving on to question number 9. ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect each other at the point O. Show that AO by BO is equal to CO by DO. So these two sides and these two sides. Given that ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect at the point O, we have to prove AO by OB equal to CO by DO. For proving, first let us draw a line EF through the point O such that in triangle ADC, EO is parallel to CD. So we are drawing EO parallel to CD. Why are we doing that? To prove by using basic proportionality theorem. AE by ED is equal to AO by OC. Okay, so that's the first equation. Now in triangle AB D. Again, OE is parallel to AB because AB and DC are parallel, OE and DC are parallel. So obviously, lines parallel to the same lines are parallel to each other. So AB is parallel to OE also. So again, by using basic proportionality theorem, we can say that ED by AE is equal to OD by OB. Now, that will be the second equation for us. Okay. We are taking the reciprocals on both the sides, and that is the second equation for us. Now from equation 1 and 2, we'll get AO by OC equal to BO by OD. Let us just cross multiply them, not completely, just one set alone. So we get AO by BO equal to OC by OD, which we have to prove. Moving on to the 10th one, again a trapezium question. The diagonals of the quadrilateral ABCD intersect at the point O, such that AO by BO equal to CO by DO show that ABCD is a trapezium. So this is again the converse of the previous question. So given AC and BD of the quadrilateral ABCD intersect at the point O such that AO by BO is equal to CO by DO, we have to prove that ABCD is a trapezium. Now for that, we are going to draw a line OE parallel to AB. So by basic proportionality theorem in triangle ABD, we'll get AE by ED equal to BO by OD, first equation. And again, it is given that AO by OC equal to OB by OD. So from these two equations, we'll get that AE by ED is equal to AO by OC. So EO is parallel to DC by converse of basic proportionality theorem. So all the sides are parallel to each other. AB parallel to OE, parallel to DC also. So AB is again parallel to DC. One pair of opposite sides are parallel. So therefore ABCD is a trapezium. Okay, with that property we are proving it. So with this we have come to the end of this topic. We'll continue in the next video. Thank you.